Hello students, I am your Mistri sir. Welcome to my channel Mistri sir classes. In these sessions, I am going to discuss another very important topic, coordination number and arrangement of packing of cubic crystal. I shall focus in this video what is coordinations number and why it is important to us. I want to telling you students this topic is very important tools to help understanding packing of crystal, how to form voids, even locations of void depends on the coordinations number. Finally, this video gives you clear idea about this topic. Watch and concentrate. I am sure by end of the topic you will be just perfect and solve maximum of the question based upon coordination number and close packing system. So let's begin the topic coordination number. Now here it is coordination number. It is represented by CN, that's abbreviated form. Now definition, the number of nearest neighboring atom or touching atom to any other constituent particles in these crystal called as coordinations number. Now first of all, how to understand now what is the sense of coordination number. That means here it is touching number. So if I draw a constituent particles like a atom, now this atom touches how many other nearest or touching atom called as coordination number. Now if I take this atom, this atom touches how many atoms are there? 2. So here it is coordination number is 2. Now I can another examples. Let's see students here another examples. Now here it is 2D crystal. So if I take in this atom or sphere, now in this atom touches how many atoms are there? How many atoms are there? 4. That means these atom, and these atom, they do not touch in this atom. So how many touching atom are there? 1, 2, 3, 4. So coordination number is 4. So types of packing efficiency of cubic packing. So this is possible in case of metals. First video I taught you this solid state mainly depends on the metals. So their constituent particles arranging in the cubic cell. So these are on the basis of arranging, these are categorized 3 type. First, one dimensional, two dimensional, three dimensionals. So first of all, I want to telling you one dimensionals. That means in which substance having a earth surface called as 1D. And what about 2D? 2D means in this atom neither earth surface nor complete space. That means they are lie between earth surface or complete space. That means it is a hanging substance, just like सर्कस में जैसे रस्सियों पे कुछ लोग जो करतब दिखाते हैं या रस्सियों पे कोई कीड़े वगैरह चलते हैं या जो कपड़े वगैरह हैंग करते हैं, तो ये इसके एग्जांपल्स है. एंड इवन आई एम राइटिंग हियर ऑल ऑफ दोज वर्ड्स, ऑल आर द two dimensionals, and 3D, that means they are like completely space. So first of all, we will discuss one dimensional. So one dimensionals, what about one dimensionals? Now close packing in 1D. So here it is very important again. So now see, close packing in one dimensional is very important and is achieved by arranging by the atom in one row. Now you can see here they are arranging in one row, and so that many touch each other, as evidently each sphere in the contact with two atoms, two neighboring atoms. Now see here, now I am draw a completely single row, and if you take any constituent particles and and they are touching to each other. How many atoms are there? Two. If I take in this atom, so this atom touches this atom and this atom, so coordinations number is 2. So next one, 2D. So again 2D, there are two types. That means two-dimensional square close packing, two-dimensional hexagonal close packing. So here it is also very important. Now first of all, we will discuss two-dimensional square close packing. Now see, now see students. Now I am draw a one row A. Now here it is another row. It is also having a, that means they are the same type of arrangement, and these first arrow just over these arrow and just over this arrow and just over this arrow, and all are the same, the arrangement of same. So here it is also known as type AA type crystal. Now if you see in this atom, these atom touches, how many atoms are there? That means 4. Now it's look like clear. Now here it is space also, but these atom touches to each other, so coordination number is 4. Here it is very important. Now see students, here it is very important. That means it have infinitive atom, just like 1D. That means they are going to more and more. So all of these I am drawing here, and here it is 2D. That means x, y and z, they are absent in 2D. That means height are absent. That means they are arranging in this type, these this type, not a this. So here it is very important. That means your all kind of imaginations applicable in this system. So how to weld, and you have to do much and much use of your imaginations power in this topic. So next one, second type. Now second type, 2D hexagonal close packing. Sorry students, 2D hexagonal close packing. Now here it is very important to arrangement. Now it is also known as staggered arrangement. Staggered arrangement, that means see, now A is A type of atom, they are the same row, and now different color having B, just like between 2 and 2. So here it is very important. That means AB type of arrangement. That means they are completely different kind of arrangement called as hexagonal close packing. Now if I take any one atom, now you are free, you take any kind of atom. So I am taking here this atom. Now this atom, how many atoms are touches there? 1, 2, 3, 4, 5, 6. So here it is very important students. Now this video gives clear idea how to coordination number 6, 4, 2. So here it is, coordination number is 6. Coordination number is 6. Now look here, that means they are different pattern, now arrange on the different patterns. Now just before I told you, that means दो बॉल के बीच में एक को फंसा दिया जाता है, और अगर इस बॉल को देखा जाए तो इस बॉल से जितने भी अन्य एटम टच करेंगे उसे ही हम कोऑर्डिनेशन नंबर कहेंगे. Now this is the third type of packing in three dimensional. So three dimensional, they are two types. First, square close packing, and second, hexagonal close packing. Now this topic very important. Now in these segments, many questions comes in many different type of competitive examinations. So students, I want to tell you, please concentrate in this here. So first of all, I am telling you square close packing. So close packing, there are again two types. First, three dimensional square close packing. Close packing, these are known as AAA type. Just before I told you what about AA type. And second one is 3D square close packing, that means AB type. Just before I told you 2D square close packing and 2D hexagonal close packing. So here it is 3D square close packing AA type and 3D square close packing AB type. So they are the basic different. So first of all, I am going to discuss 3D square close packing. 3D square close packing. So let's see. Now, first of all, we will discuss AA type three dimensional square close packing. Now see, now I am drawing before telling you students, because many time consuming here. So first of all, how to imagination in this type of crystal, that means 3D crystal. Now see here, if I draw here a crystal, this just like, now see in this crystal also how to draw. See, now this is a look like a 3D. So here it is also look like a 3D. Now see students, now here it is pattern A. Now same pattern draw above the A. That means they are aligning the same row. Same row. That means here it is the same kind of constituent particles A, and arrangement also the same A, and all kind of row, that is A. That means similar arrangement. So so now look here students, now they are length and they are weight and they are also height. That means what you have to understand students, now here it is a cube. That means they are weight, they are length, weight, weight, length and height. That means all kind of things, one face, another face and another face. It is very important. So it is very important, that means they are achieving on the height. So it is a three dimensional. So what you have to do students, now you can draw first a crystal. Now see I can use the different color. So here it is look like 3D. 3D. So how many atoms are touching to each other? That means here it is 6. So how is it possible? Now let's see here. Now what is the sense students? Now see here, it is a X and it is a Y, and it's a Z axis. That means they are arranging in 1 1 1 1 1, and here it is also 2D phase. 2D phase, all are having 2D phase. 2D phase. Now this can draw, I am also arranging the just above. That means they are, suppose my three finger is having now one pattern, one row pattern. So okay, now I am also placing the another another row here, and also another here, and also another. So they are achieving in heights, they are achieving in heights. Now how to represent in 2D structure? Now we just consider, suppose now above. So it cannot possible to draw here, but we can imaginations. So here it is. Now red color is just placing above, that means they, and red is just above, just above placing. Now another it is, now another it is, now another it is. So they are achieving in heights. So here it is very important, students. Now see here, now we can extend it from. So see the students, now green ball having first row, and red is red is just above. So first of all, now touching atoms. Now how to touching atoms in there? Now see students, one, one, two, three, four, and fifth. That means above, and sixth is just below. If I talk in front, and another is back. So here it is very important, that means how to imaginations, how to create weight of imaginations power about yourself. So here it is very simple. Now just look a cube, just look a cube. Now here it is achieving on the heights. So if I can draw one atom, another atom, and it is the another atom, just like a brisk constituent in the building. So what is the sense, student? Now here it is. So I can place a atom. Now this atom touching first here, second here, third here, fourth here. Now just a unit cell. After repetitions, again this place. If if we can consider this bottle also crystal. So here it is placing here, here it is placing here. Now same kind. So this center atom also touches this, and also this, also that. So here it is very important, students. So so this atom touches, how many atoms are there? Six. One, two, three, four, and fifth is front, and sixth is back. So here it is important. Now another fact is that, now see students, now you look like a 3D square close packing. So here it is very important, students. Now now it is look like AA type. Just before I told you. Now 2D, that means A, that means 2D square planar. So here it is square planar, and here it is square planar structure. It is very simple. Just before I see. Okay, now later on we will discuss 3D square cubic packing. So here it is very important. Now let's see. Now second type of 3D close packing. So here it is very important, students. AB, that means arrangement are the different types. So look here. Now just it's like a BCC. So what about BCC? Previous video I taught you. Okay, now see here. Now it's a below phase. Now this is the below phases, and the above phase having these phases. So here it is very important. Now see here, students, 3D structure we cannot draw the paper. So here it is, now I am drawing here a and all kind of atoms drawing here a. Now another kind, now what you have to do, students, now you can draw the above. Now I am doing here a different color. So just you can imagine just above, that means they are all black in color, and in front faces are red color, if you imaginations or understand, students, isn't it clear? Here it is very important, because these topics uh, arises many questions. So look here, students, now black black sphere or atoms having below faces, and a red sphere having the front faces. Now another atoms inside in the crystal, they don't share it in any other particles. So I am drawing here a single, that means single ball. So I am placing here. So now this body touches, how many atoms are there, students? How many atoms are there? One, one, two, three, four. Just below phases, below phase, and front face also. That means red. Even in case of red, one, two, 3, 4. So how many atoms are there, students? So coordination number is 8. It is very simple, just it is depend on the imagination's power. Now black ball having below faces, and red ball having just above. Suppose now my forefinger having first row. Just I am doing here like this, okay, like this, and these are placing just above, and in the between of one atom. Suppose I am consider a atom. Now another point is here. So here it is very important. Now this watch or atom touches, how many atoms are there? That means 1, 2, 3, 4. Now same kind of 4. So complete atoms are there in 8. So coordination number is 8. So here it is very important, students. Coordinations number is 8. Now see here it is some important facts. Now see, now here I am extended here. Now look, students, now first ball, that means a black ball having a or below face, and red ball having just above face, and the body centered atom is atom placing between first and second piece. That means the body inside of the center, that means body center. So body center, that means first black face, first black ball, and second inside of the atom, and just above plane having a red. So here it is very important, first layer and second layer. First layer is black ball, second layer that means a just above or upper layer, and below and upper, and atom are lie between first and second layer. So here it is very important, because it is being on the BCC. So first of all A, and what is the sense A? That means what is the form of A? That means 2D square cubic packing. So already we discussed 2D square close packing. And B, very important, B, that means tetrahedral voids. Now initially in this video I am telling you, students, what is the importance of coordination number. Now you will see the coordination number form on the whites. That means what is the dependence of whites, and in which substance having a form white. So it is completely dependent on the coordination number. And what is coordination number? That means packing or arrangement of atom in crystal. So here it is very important. And how to form whites, students. And this segment, I want to make the separate video. So later on we will discuss what about whites and how to form tetrahedral whites. Now just they are repeated. That means A 2D, B tetrahedral, A repeat 2D square cubic, and B forms tetrahedral whites. How to form tetrahedral whites, we will discuss next video. Okay, students. So next one, hexagonal. Next one, hexagonal close packing. That means 3D HCP, and it is also two type. There are two types. First AB type. That means 3D SCP AB types. And here it is 3D CCP. That means they are very important. Hexagonal, they are categorized two type. First HCP, hexagonal cubic packing. Hexagonal cubic packing. Here it is AB type. And another type is ABC, and it is also known as CCP or FCC. That means such a FCC crystal having FCC. That means they behave on the hexagonal close packing. That means hexagonal close packing on the behalf going on the CCP or FCC. That means in this chapter much of questions, that means about 90% questions depend on the CCP or FCC. That means any questions having generally CCP or FCC. So here it is very important. Now this topic completely very important, and all kind of competition, all kind of exam like competitions exam, theoretical exam, it is so much students. So see what happened is that now here it is very important, hexagonal close packing 3D. That 3D is hexagonal cubic packing. It is very interesting or important. Now see, now first type is AB type 3D hexagonal close packing. Hexagonal means they are having one hexagon. So here it is a hexagon. Now just look like here. That means it is having 6 atoms. It is having 6 atoms. So another type AB. Another type is that now same kind of arrangement. So in these atoms repeated just after 3 atom. Now similar way. Now this atom having also similar way. That means this apex having our front side. So another type of arrangement also having apex is front type. That means similar arrangement. Now this arrangement same kind as this arrangement. Now this arrangement having same kind of this arrangement. So here it is very important. See students, now I am here about type of structure having. Okay, now see here it is a hexagon. Now here it is a here it is triatoms. Triatoms, it is so much important. That means first layer, second layer, first layer, second layer. That means first layer and second layer having same, and second layer and fourth layer having same. Here it is very important. Now what is the sense, student? Now A, what about A? Now first of last time I discuss that means 2D square cubic packing, 2 DSP, and B having tetrahedral whites. Just before I told you, that means A to form 2D square packing, and B to form tetrahedral whites. tetrahedral voids. They are very simple. So how many coordination atom in there? Now see here, students. Now inside of the body, now just look like here, just look like here. Now if you see now 1 2 3 4, now you look like 4, now fifth here and sixth also here. Now these atom, these particular atoms touches how many atoms in there? That means 6 and 6. So coordination number is 12. It is very important, student. Just previously I taught you, that means it's just depends on the imaginations power. And how to imaginations? Just see students, 1 2 3 4 4 5 6, they are the back side. And these atom surrounded, how many atoms are there? Sixth. That means above, that means there are four. You consider a six atom here. Now here it is three atom. Now one atom touches second atom and third atom. That means a main atom, now another atom, and having another kind of atom, another, just like here, just like here. Okay, just like here. Now see here, see here. Now this atom touching in this six atom, now this atom having in this six atom. Now see here, now see in this atom, in this atom they and two atoms are where? That means in side of these. So six atom touches in this sphere, and six atom touches in this atom. So how many coordination number? So coordination number is 12. And last topic in this video, hexagonal close cubic packing, or it is also known as FCC. So here it is very important. Now last topic we discuss BCC like structure, BCC like structure, and here it is FCC like structure. So now second type of hexagonal close packing system, here it is ABC type cubic packing, type packing. Now see the structure. Now here it is hexagon, here it is hexagon, and they are arranging in three atoms. That means tetrahedral voids. That means a first layer repeats itself in fourth layer. First layer A, second layer two atoms, third layer one atoms, and fourth layer now similar repeated itself. And after these repetition, this group repetitions, they are changing this type of apex. Now change in apex. Now previously, that means hexagonal HCP, they are having the same type of apex, but this apex just opposite, just opposite. Now see students, I told previously. Now here it is a hexagon, and now these atoms, this atom look like a same, and another, that means A row repeated after second. That means 1 2 3. That means every third row having same A and B also. But here it is some different. Now just look like here. Now A, it is completely same, and B also we consider as same. But C, they are just different. That means apex are changes, complete changes. Now if I consider this type of arrangement, this type of triads apex having front, so these are back. That means I can draw. Now see how to draw. If I draw a triangle, okay, now I consider I consider a back apex. Now look like a back apex. Now what is the front apex? Now see here students. Okay, here it is front apex, just front apex. So here it is the basic difference SCC, HCP and CCP. It is very most important things. So here it is the similarly touches how many atoms are there? 12. Here it is very important. So see the basic difference of SCC, HCP and CCP. Now this will be clear idea. Now what is the basic difference of SCP and CCP? Now a stacked view, if I see and you also see, now here it is how many atoms are there? 6. Now these atom touching this 6 and this 6. So how many coordinations number are there? 12. And now see the basic difference HCP and CCP. Here it is very important students, very important. Now see here 6 atom are here and 2 atom are here and single atom are here. So these group of unit cell group of arranged repeat just after opposite in directions, but not only a. Now it's just opposite on the apex of B and C. Okay, now one time having it's a front faces. Now just after repetition they are back faces. So here it is very important. Now see, now a exploded view. Now see here they are same pattern. Now it is also same pattern and it is also same pattern. That means A type of arrangement and B type of arrangement, they are completely same just after uh, interval. Now similarly CCP having a different kind. Now see here it is A type of arrangement and B here it is A type, just A type, that means this type of arrangement, and C also just opposite apex, just opposite. Now they are the same apex, same hexagon, but here it is hexagon are same, but this B and C apex are always opposite in directions. So here it is basic difference. So I hope you like this video. If you like this video, please like, share and comment. And if you want to get more notifications about my channel, so please press the bell icon button. Thank you.